Here's another proportion question. So it's given that p is directly proportional to the square root of q plus 1 and that p equals 3 when q equals 35. We need to find the value of p when q is 99, the value of q when p equals 4, and then we need to determine what real values of p and q is the equation 2p plus q is equal to 155 satisfied. By the definition of direct proportion, we know that p must be equal to a constant k times the square root of q plus 1. And then we can substitute the values of p and q being 3 and 35 respectively. So it will be 3 is equal to k times the square root of 35 plus 1, which is just the square root of 36 or just 6. This leaves us with the value of k being a half, which means our equation turns into p is equal to half times the square root of q plus 1. Now that we have our equation, we can solve part A and part B. For part A, when q equals 99, p will be equal to half times the square root of 99 plus 1 or just 100. This will leave us an answer of 5. And for part B, when p equals 4, we can set an equation in terms of q. That will be 4 is equal to a half times the square root of q plus 1. That leaves us with a solution of q being equal to 63. For part C, this is pretty interesting. We can substitute the value of p being this expression right here into our equation to get 2 times a half times the square root of q plus 1. And the reason we're doing this is that we're going to set this equation in 2 variables to an equation in 1 variable so that it becomes much easier. So anyways, this becomes plus q is equal to 155. Notice that these twos cancel. This will be square root of q plus 1. Now what I'm going to do is I'm going to move this q to the right hand side. That'll be 155 minus q. And then we can just square both sides to get that q plus 1 is equal to 24,025 minus 310 times q plus q squared. Rearranging this will be q squared plus 311q minus 24,024. This must be equal to 0. Although our numbers right here are pretty big, I can tell you that this factors nicely into q minus 143 times q plus 168. These renders two solutions being q equals 143 and q equals negative 168. However, q equals 143 is the one and only valid solution to this problem. Because notice that if you want to substitute the value of q being this thing into p, we notice that the square root of q plus 1 will be not a real number. So we can't have that, so our solution will be q equals 143, and then if we substitute this value into our equation for p, this will leave us our value of p being 6. So these are the solutions, which ends this video.